Hello guys. How are you doing? Today we're gonna go with the I'm gonna check the audio first. Today we're gonna go with the that's good. I'm gonna put the output is gonna be here, my Sukavki. That's good. Okay, perfect. Perfect guys. So basically today we're gonna go with the second part of the third course of the AI associate path for developers from DataCamp. Now we're in the second part of the text course. In the first part, we learn how to install HUGGINGFACE, how to connect it via Python, just call some basic models so to fetch some of the data sets. I have some of the code here. I'm gonna push it later when I finish today's course onto GitHub so you can have a reference for it. And now we're gonna go with the second parts of the course. So as you may see here, I have here some of the code. I'm gonna push it to GitHub later, but let's go with the second part. Okay, let's go right into it.
Welcome back. Let's dive into a specific task in machine learning, text classification. Text classification involves assigning predefined categories to text. A common example is sentiment analysis, where text is labeled based on its emotional tone. For instance, the sentence "I love pineapple on pizza" is labeled as positive, while "I dislike pineapple on pizza" is labeled as negative. This simple yet powerful technique helps uncover opinions, emotions, and attitudes from text in applications like reviews or social media analysis. Recall that a sentiment analysis pipeline can be created by specifying the text classification task in a model pre-trained for this task. Let's call the pipeline on an example sentence and display the results. The model correctly labels the sentiment as negative, assigning it a high confidence score. The next type of text classification is grammatical correctness, which checks text for proper grammar and labels text as acceptable or unacceptable. For instance, "This course is great" is labeled acceptable, while "course is gravy" is labeled unacceptable. This task is useful for grammar checkers and language learning tools. To assess grammatical correctness, we use a model trained for this specific task. For instance, the sentence "he eat pizza every day" is labeled label_0, meaning incorrect grammar, with a confidence score of 0.99. Another type of text classification is question natural language inference, which checks if a premise answers a question. For example, the question, "What state is Hollywood in?" paired with "Hollywood is in California" is labeled as entailment, true, while "Hollywood is known for its movies" is labeled as not entailment, false. This task is especially useful in question answering systems and fact-checking applications. For Q and LI tasks, we use a model trained to evaluate question premise pairs. When calling this classifier, we must pass both the question and the premise separated by a comma. In this example, about where Seattle is located, the premise provides enough information to answer the question. The model labels it as label_0, entailment, with a high confidence score. The next type of text classification is dynamic category assignment, which assigns predefined categories to text based on its content. For example, classifying the request, "I want to know more about your pricing plans," into categories like sales, marketing, or support. The model assigns a confidence score to each category, with sales receiving the highest score in this case. This task is widely used in content moderation and recommendation systems. To perform dynamic category assignment, we use a task called zero-shot classification. This allows the model to assign predefined categories to text, even if it hasn't been trained specifically for those categories. In this example, we classified the text, "Hey DataCamp, we would like to feature your courses in our newsletter," into the categories marketing, sales, and support. To retrieve the category with the highest confidence score, we access the top label and score using index 0. Interestingly, the model chose support over marketing, but remember, it hasn't been trained specifically for these labels. Text classification faces challenges, like ambiguity, where text...
Alright, I'm gonna check this. Text and categories. Alright.
It hasn't been trained specifically for these labels. Text classification faces challenges, like ambiguity, where text has multiple meanings, sarcasm or irony, which are difficult to detect, and multilingual complexities, requiring tailored processing for diverse linguistic structures. Addressing these issues demands advanced preprocessing and more robust models. Time to practice.
Good. So, text classification is the process of labeling an input into text and a predefined category. This can take I get my notes. This can take the form of something positive or negative, spam detection, spam not spam. I read it. Okay. So this exercise is gonna be about text classification, and I guess we're gonna classify the text if it's grammatically correct or not. Checking an input sentence for grammatical errors, pipeline, and transformers. So I should code here pipeline for a task text classification. So I should define here a task, and the model is gonna be this one. This is gonna be the pipeline is gonna be grammar check, and I'm gonna run the grammar check here. So if I run the code, it puts the label, and I should be, here's the score. Okay, the only thing is that it doesn't tell me exactly what the label means. So you know what, I'm gonna create another one, another file here for, it's gonna be text classification grammatical correctness, and I'm gonna, and this is gonna come from the pipeline. I'm gonna do this. Then I'm gonna go to cloud, and I'm just gonna make sure that this stuff here is not too heavy, or maybe how heavy is to download one from Hugging Face. Because I don't want to run something that is like too heavy, and I wanna make sure that I don't download things that I'm just gonna use for testing. At the end of this course, I'm just gonna run a script to just like don't remove all of the models that I have or datasets that I have in my local machine, so I free up some space. Because it's not necessary just for learning right now. Even though we can also, just as a test, I think we can go here and we can just try to 6,000 downloads. Loss as well as a find word basic files and versions. Okay, training metrics. $440 megabytes. Okay, and if I run this, how much will it be downloaded? Wait. Oof, it's gonna download too much. Okay, can you recommend some other one? Because I just want to run a contest. So I think it's good. Training metrics I don't need. All right. So I'm gonna do it with this one, which is going to be but just in case classifier for grammatical correctness. Okay, let's run this. Albert base cola. So label 0 is grammatical, label 1 is grammatical. So if it's not grammatically correct, it's gonna get 0. So in this case, I will walk doc. If I run this, which is gonna be the fourth, this one, but this one here. I'm gonna minimize this because I don't need that. It's gonna be Python 4. So it's gonna download this model, and it's also gonna run this. It's classification. Another question that I have is like somewhere here in the documentation I should have, okay, maybe in the readme files. Where in the documentation it's shown the usage of the expected output results. I'm just gonna use Opus 4.8 because I don't need the other one. And so here is not. Here is still downloading probably. Yes, loading waits. Here's finished. And can I upload this? This is an error of the I'm gonna close these two other ones because I don't need it for the moment. And I'm gonna run it again because maybe I'm not passing correctly because of this comment that I did in the middle. Nope, still the same. You are an expert. Engineer specialized in Python. You're getting this error while running this file. Can you please analyze what is going on? Can announce this because here it ran correctly. Label 0, it means that it's ungrammatical. I want to figure out in which part of the documentation So here's the pipeline with the task and the model. Okay. Okay, but what about the this is okay. So basically the label is defined inside of each. Yeah, that's model specific. I imagine that. For example, here, text attack cards. Mention also item and color classification. So if it's not if the author didn't customize it, you get a generic label 0 label 1. Follows the dataset convention. For the color that's documented in the dataset. So I think it wasn't defined here. Here is saying that I should check the config. So it's also not defined. I don't see it here. So then it means that it's gonna it needs to follow. So every time that I don't have anything defined, I should go into the data set. ID to label. Okay, so if just for the moment to just make progress, normally it should be I can do this, so I can print what is the mappings of the label to the ID to the label, and then if they don't specify what does the label mean, that means that if it's label 0 and label 1, that's the default, and it's following the dataset classification. So I'm gonna do this print, and I'm gonna also print this output here. I had this error too, so I'm gonna check why it's not running here. And well, let's go to the next one. Another task under the text classification umbrella is a question natural language inferences, or this check if a program contains enough information to answer a post question. Okay, so this is one of the topics that they were talking about in the lecture. That basically you in this kind of question natural language inference, you have a question and you have an answer, and you check if the answer satisfies the question. From different tasks with this classification probably can be done by choosing different models. Each model is trained to predict specific labels. Okay, so assume that I should put here the model. The task is gonna be text classification. Here I'm gonna do the pipeline, and the pipeline is gonna be called classifier. Then I need to call the classifier function, and this is gonna be the output, and then I should run the code. So I mean, label 0 means that it doesn't return the first time because like yeah, because it doesn't. And a sentence piece library, and when that's missing, the transfer file to TikTok, which is also missing. Okay, let's just let it install. But what is better is that I'm gonna do tell me the command to install it, but for user, the current user, because if I think for some reason Cloud is not allowed to install any library, which technically is good, because I don't know, you cannot fully trust, you know. And meanwhile it's installing, we can see that it's good. And let's also do the 5. It's gonna be 5 question natural language inference. And in here I still do this, but I'm gonna call this let's close some of this stuff that I don't need. And if I run this, how is the model download? Okay, it installed, and then I can run the text classification for the previous exercise, which is the number 4. And let's see how it rolls. 440 megabytes. Okay. Can you recommend a smaller one just for local testing? So when I run this and I run this grammar check with this model, I will walk doc, and I got the label 1, which means that it's acceptable. So it's checking it, that it's telling us that it's grammatically correct in English, which is wrong. And that's why also the parameters of the model matters, because probably this model is like not too smart, doesn't have enough data to actually check correctly that this sentence is not correct in English, because here to be correct it should be I will walk a dog, and it's not correct. Probably the other model here, this other model might be smarter and might check it better, but so far for testing purposes this is not the output is better results. Let's say for example if I do hola, ¿qué tal? this definitely should show like level 0 because this is not in English, you know. If it doesn't classify this correctly, that means that it's really, really bad model, from my opinion. Uh-huh. Okay, let's do. So it's not doing this correctly. Uh-huh. So this is really small. I don't want to download 330 megabytes. No, guys. So it's gonna be. So probably like this model is like really, really, really bad. So I just leave it there as a reference. If you want to run it locally, you know how to run it locally. But I don't want to be downloading models for each question. In the other one, also like it says that the for Q and LI specifically, like my top, like my top bottom, like download is 330 megabytes. So I don't think it consumes too much. So I will just leave it there. I think our top is max 30 megabytes. We are running low in this space, so I don't want to download too much things more. But well, I just see here it works. It's classifying it as it doesn't classify correctly the question, so it classifies correctly that it's not a proper answer to the question. So let's just run this. Now, dynamic category assignment. Dynamic category assignment enables a model to classify a text into predefined categories, even without prior training for those categories. Okay. So I can define here the task. Here's the model. Here there's 3 categories: politics, science, and sports. The pipeline should be named as classifier, and I should classify the text, and I should put the categories here. And if I run the code here, this should be 6, and this is called dynamic category assignment. And I'm gonna have these. Well, let's submit this. It worked good. Just in case, just to summarize here, like basically with some models, what we can do is we can just pass our text, we can pass our categories, and the model can classify. I'm gonna ask again also if I run this locally, how much will be the model download size? $1.6 gigabytes. No way. It's good that it's running on cloud. Text summarization. Welcome back. Let's move to another natural language task. Summarization.
Welcome back. Let's move on to another natural language task, summarization. Summarization is the process of reducing a large piece of text, such as this one, into a smaller one while retaining key information. Summarization can either be extractive, where key sentences from the input text are selected to form a summary. This method is efficient and requires fewer resources, but often lacks flexibility and may result in less cohesive, easy-to-read summaries. On the other hand, abstractive summarization generates new text that captures the main ideas, while rephrasing for clarity and readability. Though more flexible, it demands more computational resources and processing. Extractive summarization is ideal for tasks like legal document analysis, where key clauses are highlighted, and financial research, where main insights are extracted, both requiring accuracy and ensuring no new content is fabricated. Abstractive summarization is ideal for tasks like news article summaries, crafting concise and readable overviews, and content recommendations, generating compelling descriptions, both focused on delivering clear, engaging, and impactful summaries. To perform extractive summarization, we create a pipeline by specifying the task as summarization and selecting an appropriate model designed for extractive methods. Next, we pass in a large piece of text, such as this one on data science, into the pipeline. The output is a dictionary containing the summarized text. In this case, the model selects key sentences from the input, producing a concise and fact-based summary, while preserving the original phrasing. The key difference in implementing abstractive summarization lies in the chosen model. Here, we use the distilled BART model designed specifically for generating abstractive summaries. We pass the same input text into the pipeline. This time, instead of extracting sentences, the model generates a more natural, concise, and readable summary. However, unlike extractive summarization, it may introduce fabrications or information not present in the original text. In summarization pipelines, parameters like min new tokens and max new tokens control the length of the generated summary in tokens. Tokens are smaller units of text, such as words or characters, that language models process to generate results. These parameters ensure the summary is concise, meaningful, and not overly verbose. Now that you've explored the key concepts of summarization, it's time to put these skills into practice.
Nice. So, wait, I'm just gonna make something here because I need to just clarify something. What is the key difference? I just want to show what is the key difference between extractive summarization and abstractive summarization in NLP, natural language processing. So in extractive you reuse the original text, and in abstractive you generate new text. The meaning of, you need to capture the meaning of source. That way a human will rephrase it. Current risk of hallucination. Source. George giving extractive summarization. Nice. So in extractive, sex and copies most important sentences, like highlighting the key sentences in an article, text rank. Well, that's interesting. Summarizing long text. Summarizing readers large text into manual content, help readers like quickly grasp key points from lengthy articles or documents. There are two main types: extractive, select the key sentence, and abstractive, which is a new sentence. And extractive summarization, so we're going to generate new sentences using the HUGGINGFACE pipeline function and the CNICU. You'll summarize text from a Wikipedia page on Greece, comparing the structured model rephrase output to the original. So the model is defined here. I need to define the task, and the task should be summarization. This is a pipeline. The summarizer of the original text, and here in the, probably is here in the documentation, HUGGINGFACE, maybe here. Here I might be able to see. It really exists, but it's empty. Not good. But anyway, let's run the code. Oh, what do we have here? Name CNC is not defined. What do you mean? Maybe I need to reload the whole page. Sometimes this is the issue. This is gonna be 7. struct summarization. So I need to put the summary text. Summary text. Because this is a variable. And I'm getting the result, the summary text, and the length. So that should be all right. You know what? I want to print also the summary because I want to know what is the result of this. I want to see what does the object look like inside. So it's an array. Well, a one element array with the object is a one element array, and each element is a dictionary with only one key, which is summary text, and this value is the summary actually. Okay. All right. Let's submit the answer and let's go to the next exercise. Just in case I'm not running these codes because I'm not downloading this model. I don't want to download these models because it's gonna take space on my machine and I don't want that. The pipeline for testing for minute tokens and maximum token. There is for just the length or the summary text to be short or longer. There are space constraints, small storage. Yeah. So I'm gonna call the pipeline again, and I'm gonna define here the mean new tokens, which is gonna be 1, and the max new tokens, which is gonna be 10. And I'm gonna call this function with the original text, and here I will see that the summary is now limited to this, just in case the tokens are not the number of words. So I'm gonna call this summarization length, and there's gonna be 8. I got a really nice idea because I think at the end of this whole course I'm gonna make like probably I can run like a task on Cloud Coworker somewhere that it generates like the whole new course, but even much more optimized for developers, so we don't repeat some things. So far in this Hugging Face we didn't repeat nothing from the course 1 or 2, but in the course 2 there were some things that were repeated and I didn't like that. Okay, we get this, we delimited this. Okay, now we need to do the same, which will be menu tokens, and this is gonna be now 50, and the max new tokens is gonna be 150 according to the, and it's gonna be a long summarizer, and this is gonna be for the second task. I should run this, and then I'll submit it. Nice. Okay, that's good, guys. Now I'm gonna take a small break because I need to eat some food, and then we're gonna be back in a moment. All right, so see you in a while.